Welcome back. Let's resume. We went through the first two problems already, so let's begin with 1.3. If the 90% upper confidence bound is 63.5 miles per hour, what is the standard deviation is the problem. In this case, we don't know the standard deviation. In 1.1 and 1.2, we used the standard deviation of 4.95. The standard error was 4.95 over square root of 76. This time we don't know the standard deviation, so we have to go backward. How does it work? 90% upper confidence bound is 63.5 miles per hour. Roughly speaking, this corresponds to 90th percentile. And here's a picture. 62 was the observed mean in the sample study, and 63.5 is the upper bound. It's upper confidence bound. Keyword upper, so it's bigger than 62. And the problem said 90% upper confidence bound, so this shaded part is 90%. Because this is upper bound, the probability of the real mean falling below this upper bound, this blue region, is 90%. So with this, let's find out the standard deviation. And based upon that standard deviation, we may have to do something in 1.4. Now, how do we do that? Well, here's the picture. Picture says a lot. And then let's solve this problem. Now, what is the z-score? End minus center over SC is the formula, isn't it? Let me extend the font a little bit. And in this particular case, end is 63.5. Look at the picture. Center is 62.0. And what is the standard deviation here? Standard error is SD over square root of n. Square root of n, the sample size, we have that. And standard deviation, well, let's use Greek letter sigma for that, which is traditional symbol for standard deviation. And that's approximately the same as the z-score associated to this picture. 90% to the left, 1% to the 10% to the other side, excuse me. So 90% here, so you have to look at the 90th percentile. How do we do that? Well, here is the z-table. Okay. And let's see, you have to look at the second page. This probability has to be 90%. So look up all these numbers and find out the z-score closest to 90%. Where is it? This is it, isn't it? 0.8997 is the closest. The other one, 0.9015, is a bit too far away. So let's approximate it as 0.8997. Okay, 0.8997. That's equal to 0.8997. And let's solve this. Is this right? Well, if this had been in class, at this time probably somebody must have raised hand or spoken up. I hope everybody saw that. Something's wrong. I just did this because while I was grading something the day before, there were some people who did like this, so that reminded me of this. This is not the place for probability. This is place for z-score. So 0.8997 is the probability, and the z-score associated with this probability is 1.28. This is coming from 1.2 row and 0.08 column. So you have to look up the z-table and get right z-score of 1.28. Now this equation is complete, and you can solve for the sigma from here. All right. Looks good, and let me just show you the answer key here. Well, instead of 1.28, I use technology to get a little bit more accurate z-score, 1.28155, which is a little bit better. And the right-hand side is the same, and looking for sigma. How do we do that? Switch its denominator with the other side, and sigma over square root of 76 is this quantity over here. And if you calculate out, we have something like this, but that's not really necessary. I usually like to delay the computation toward the last step. So multiply this denominator out to the other side, we have this expression. Then we have calculation about 10.2. The detail is left to the students because this is just a simple algebra. The standard deviation should be about 10.2 miles per hour. And that is the figure you should be using in the next problem. Now, do we have enough time for a digression? Okay. And let me copy and paste this problem because I don't want to disturb the original. And let me modify this problem a little bit. Instead of the 90% upper confidence bound is 63.5, let's do some lower confidence bound. And instead of 90%, let me choose something else. Say, okay, 92% lower confidence bound is, oh, that cannot possibly be 63.5 because it should be lower bound. And the observed mean is 62.0, so lower confidence bound should be lower than that. Anything less than 62 will be acceptable. Okay, on the spot I change like this. 92% lower confidence bound is 61.2 miles per hour. What is the standard deviation? Very similar to 1.3, except that this is lower confidence bound and some other numbers. Okay, and initial picture, of course this is not right. I have to correct it. We have to have lower confidence bound, and this should be 61.2. And you don't really have to understand all these details of this program I wrote. Let me just show you the picture. Okay, here we go. This is a modified problem. This is a picture associated to the modified problem. Here we go. The center is 62 miles per hour as before, and its lower bound so comes to the left hand side, and this is 61.2 miles per hour and 92% lower confidence bound. So 92% comes this big part. Certainly this left hand side cannot be 92%. This bigger one should be 92%. Another reason, this is lower bound, so the interval where I'm expecting my real mean to be is 61.2 or higher, all the way over here in the red region, and that is going to be 92%. So what do we have to look up as a z-score? Do I have to look up 92%? No, not really. In this z-table, the shading is always to the left hand side. See, shading is the left hand side. So 92% is the red part, but left hand side is the other 8%. So you have to look up 8% in the z-table. In short, you have to do something like this. And let me expand the font a little bit. Z is n minus center over SE, right? What is the end? End is 61.2. And then the center is 62. And standard error is, we don't know the standard error. It's standard deviation over square root of n, where n is in this case 76. And that is equal to, approximately speaking, the z-score associated to this picture. Not 92%, blindly because the problem says 92%. Draw the picture and you have to look up 8%. Okay, here we go, 8%. Where is 8%? Which one is the closest to 8%? Is this closest? 0.0808. Is that the closest? Looks like it. So that's associated to negative 1.40. So that's about negative 1.40. Let's solve this equation. We are looking for the sigma value. This denominator and the other side, we can switch them. In other words, this becomes negative 1.40 and this one becomes sigma over square root of 76. If I just multiply out the square root of 76 to all these, I'm gonna get my sigma value. Sigma is approximately equal to square root of 76 times this quantity. Okay, let's calculate this using your calculator. I have calculator with me, so I'll use Mathematica to calculate. What do you get? I get 4.98 something. And that is the standard deviation associated to this picture. If the 92% lower confidence bound is 61.2 miles per hour, what is the standard deviation? The associated picture is like this. 92%, the red part, the big part. 61.2 is a little bit less than 62. And this one is 8%, and you have to look up the left-hand side. 8%, not 92, but 8% from your z-table. And that's how you get negative 1.40. After that, it's just the algebra. Okay, entire problem is in the same viewing window. You can always pause and then study further, but I don't have that much time, so let's go over to the next problem and let's complete this. 1.4, find the 97% confidence interval using the standard deviation of 1.3. In 1.3 we got standard deviation of 10.2. Do you remember? 10.2. So we're going to use 10.2. Here is the initial picture. We are looking for 97% confidence interval. 97% here. So 3% is shared in the blue left hand side, in the red right hand side. So 1.5% here, 1.5% there, 97% in the middle. And we're looking for this x and this x2. And let's find out the left hand side value first using the same formula. N minus center over SC is the z-score associated to the problem. Let me copy this picture again here so that I can see this in the same viewing window here. X minus center over 10.2 over square root of 76. Yes, we get that, and z-score associated to 1.5% there turns out to be negative 2.17. Is it? 1.5%. What is 1.5%? Well, here it is. 0.150. So negative 2.17. Negative 2.17. Negative 2.17. From that, just an algebra. Flip denominator to the other side. Flip mean to the other side. Calculate. You get 59.46. About 59.5. Now, to the right hand side, we just change this negative to positive by symmetry. do the computation and we get 64.5 approximately speaking. Here is the conclusion.